In UniFi Wi-Fi setting, there is a multicast and broadcast control setting. From the tooltip, you can clearly see what it does and what its effect is. It will block multicast and broadcast traffic to Wi-Fi clients, and it will reduce airtime usage. So the background for this setting is, in wireless traffic, it's very difficult to deal with the multicast and broadcast frames. In my previous video, I mentioned briefly about the technical reason. So in this video, let's dig deeper to look into the backend of the access point. Let's use packets capturing to understand what will happen if you enable or disable this option. This is my lab environment. I use two UniFi access points and connect a Mac Mini to the XGS and a Apple TV to the Pro Max. I will run two Wireshark sessions, one running within this Mac Mini to capture Ethernet frames. The other one, I will run it in a separate Mac machine to either capture the Ethernet frames of this UniFi access point or directly capture the wireless frames on the air. And I will talk about multicast control, then broadcast control. For broadcast control, I will use two access points and two Mac Minis. In the end, I will briefly mention what if you have multiple VLANs, how the multicast control interacts with another MDNS setting, which is about MDNS reflection, how these two settings work together. Okay, let's get started. Let me talk about the network setting first. You may know, to maximize the connectivity, Apple TV utilizes not only MDNS but also Bluetooth to advertise its services. But for this video, we want to focus on Wi-Fi, focus on MDNS only. So in the Mac Mini, I already made sure for Bluetooth, I have it disabled. And for network, I also disabled the Ethernet connection. So the only way the Mac Mini can communicate with the Apple TV is through Wi-Fi. Okay? And now from the UniFi network application, you can see I do not have the multicast and broadcast control enabled. Based on the current setting, I have launched three Wiresharks. They correspond to the three Wiresharks I draw in the diagram. So let me start them one by one. From the Wireshark, which monitor the Mac Mini, let me simply capture the Wi-Fi interface. You may know in this way, I'm only going to get the Ethernet frames instead of wireless frames. That's exactly what I want to see because I want to see the MDNS traffic. So let me start the capturing. You can see I already specified the capture filter, which is UDP part 5353, which is used by MDNS. So start it. And in the Wireshark, which capture the access point traffic, I'm going to use SSH remote capture. I'm going to SSH into this U7 Pro Max. And for the capture parameter, I only want to capture the RJ45 part traffic. Even though I'm going to SSH into this access point, I don't want to capture the wireless interface here. I only want to capture the RJ45 part packets. And in the same way, I specify the remote capture filter. Start it. And then in this Wireshark, I'm going to capture the Wi-Fi frames, the real wireless frames. I cannot directly capture them using Wireshark. Instead, I'm going to use macOS built-in sniffer to capture Wi-Fi frames. Because these two access points, they use different frequencies, so I need to capture the packets twice. This parameter is for the U7 Pro Max. So let me start capturing. Okay, started. So far, I haven't started any testing yet, but in the captured MDNS packets, you can already see the gateway .1.1 has been very busy sending out the MDNS queries. Later, we will go back talking about the gateway IP addresses. But for now, let me initiate some MDNS query. So from the screen monitoring, let me click on this button. Let's pay attention to the two Wiresharks. Okay, I can find the .1.15 file, which is this Mac Mini. It is sending out a lot of queries right after I click the screen mirroring, right? In this Wireshark, you can see the same packets. However, I don't see the reply from .1.226 after these packets. Yes, now you see something from .1.226, which is from Apple TV, but they were not related to my action. So for my action, I didn't receive any reply from Apple TV. Why is that? This is due to how MDNS works, because each device will maintain its own cache or information regarding MDNS services in the network. So the Apple TV doesn't have to respond back if the client, the Mac Mini, already knows the Apple TV's existence. So just to show you the effect of the response, let me force the cache to be cleared. Then you will see the effect right away. Let me go to a terminal, then run this command first. What I'm saying is I want to clear the DNS cache. I want to flush cache. Okay, done. Then run this command. I want to hang up the MDNS responder service so that the system has to start from scratch to requery the MDNS information. So let me hit enter. Pay attention to the two Wiresharks. Okay, so see what happened. Let me stop capturing in all the three sessions. Then let's examine the packets captured. You can see these packets from .1.155. They were before I cleared the MDNS cache. But right after this packet, see, I got a reply from Apple TV from .1.226. The Apple TV advertised its existence. It provided the screen mirroring service. In this Wireshark, we can see the same thing. So after the .1.155 send out query, the Apple TV respond, right? Then from this Mac session, it's tricky because it's capturing the wireless frames, not the Ethernet frames. We won't be able to directly see the MDNS, but we can still tell from the nature of the frame whether it's multicast or not. Let me show you. I just opened the captured Wi-Fi frames. I just set the display filter to wireless LAN source address equals to this MAC address. From the diagram, you can see this is the Apple TV's MAC address, right? I can see a lot of packets. See what's the destination? It's IPv4 or IPv6 multicast destination MAC address. So this frames are for the MDNS multicast packets initiated from the Apple TV. At this moment, when the multicast control is disabled, everything works as expected. We see all the packets we expect. Especially on the air, we can capture the MDNS frames as well, which means the access point hasn't blocked any multicast traffic. By the way, for this Wireshark session, which captures the wireless frames, theoretically, I need to show you the two access points frames, right? But they are very similar. In the interest of time, for this scenario, I'm only going to show you this U7 Pro Max. So we can move on to the next scenario, which is what if we enable the multicast control. In UniFi network application, for the SSID setting, let me enable multicast and broadcast control. So you can see you have an extra option. You can specify exceptions. We will discuss these exceptions later. For now, let me simply apply changes. So it's active in both of the access points already. Let me SSH into the U7 Pro Max. Let's see what really happened in the backend. To figure out the change, I need to first tell what's the internal Linux interface name for this SSID. So I'm going to run IWDEV. You can see it lists all the wireless interfaces. I can easily tell the ATH file is the one I want because here it says SSID. This is exactly what I configured, and I can also confirm from the frequency. and the channel width, right? So my interface is ATH5. Then let me run IWPRIV ATH5. This IWPRIV is used to set the chip specific settings. So a lot of features for UniFi access points are implemented by simply setting corresponding configurations by using this IWPRIV. It will talk to the driver, and then the driver will talk to the chip. By running this command, I will see all the available commands for this particular access point, for this particular SSID. So because there are a lot of them, right? Let me filter it using BC filter. Basically, it means broadcasting filter. Let me run it. Okay, I can see 5 commands available. So the one directly related to our setting on the front end is whether this feature is enabled or not, right? So to change it, you call this command. To get the current value, you call this command. So let me copy this command. Then let me run the IWPRIV in this way, so I can get currently whether it's enabled or not. Okay, you can see the value is 1, which means it's enabled, right? So we confirm after we set this setting on the UI, the configuration is enabled. But you may wonder, what about this setting on the UI, the exceptions, right? It's directly related to these 2 commands. So you can call this add BC filter Mac to change the exceptions. Then you can call this command to get the existing exceptions. Based on the UI, because I haven't added any exceptions, right? You may think, okay, the current list must be empty, right? You will be surprised. Let me call this command. See, we have a long list of MAC addresses already. Let's investigate to see what they are. See these highlighted MAC addresses? They look very, very similar. The only difference is in the very last digit, right? What they are, if you count them, you will find out you have 11 of them. Does the number 11 ring a bell? See the diagram? I use UDM Pro. UDM Pro has exactly 11 physical parts. So let's confirm whether these 11 MAC addresses have anything to do with the 11 parts of my UDM Pro. In the left side, I already SSH'd into the UDM Pro. Let me simply run IP link. Then you will find out, yes, these 11 MAC addresses are exactly for the 11 physical parts. So let me randomly show you, right? See, this one ending with 21, it corresponds to the very first part. See, this is the MAC address, right? And see the very last one ending with 2B, it should be Ethernet 10. Let's see. Yes, exactly. This is the MAC address for Ethernet 10, which is the very last physical part, right? So these 11 MAC addresses are for the UDM Pro. And then see what's the very last one. Let me go to UniFi Network Application. Go to devices. This SSH session is for the U7 Pro Max, right? If I click on the U7 Pro Max, in the right side overview, you can easily find out the MAC address. See, this is exactly the very last one listed in the exception list, right? So what these 12 MAC addresses mean exactly? It means, yes, on the UI in UniFi Network Application, for this SSID, you enabled multicast and broadcast control. However, internally, to make the system still run, to avoid breaking the system automatically added several exceptions. For example, for all the parts from UDM Pro and this access point, they can still freely send out multicast or broadcast frames through Wi-Fi, just to make the system still up and running, okay? But for any other devices, your own devices, if you want them to still send out multicast or broadcast packets, you have to add them into the exceptions. We will do that later. For now, I hope you are clear about where these 12 MAC addresses even come from, right? Now let's go back to Wireshark. Let's see, after we enable this setting, how the system behaves differently. Let me restart packet capturing in the 3 MAC sessions. In this Wireshark, let me start the the Wi-Fi interface capturing. And in this Wireshark, using SSH remote capturing, capture the same RJ45 part. And in the third Mac machine, let me capture the Wi-Fi frames. Then from the Mac Mini, let me go to the screen mirroring, click on this button. Interesting, I still see the Apple TV show up. If we examine the captured packets, see the highlighted example packets, they were sent out from the Mac Mini to the Multicast address. You may ask, after we make the configuration change, the access point is supposed to drop Multicast packets, right? Why here we still see the packets? See, their source is the Mac Mini. So the access point cannot prevent the Mac Mini from sending out Multicast packets. But once the access point receives them, the access point will drop them, right? Then see the conversations between the Mac Mini and the Apple TV. Yes, the Apple TV did respond back, but see that response was in Unicast. And see the Mac Mini did send out a query to the Apple TV, but that query was also in Unicast. So I don't see multicast communications between the Mac Mini and the Apple TV. And we do see a lot of multicast packets sent out from the .1.1 gateway IP address. But that's already clear because we know the access points don't really block the multicast frames sent out from the gateway, right? So based on these captured frames, we don't really have problems. However, we do have a problem, which is why Apple TV still show up in the screen mirroring. You know what? It's due to the same MDNS cache reason. So let me run the same two commands again in terminal. Clear cache first, then hang up MDNS responder. Okay, now you can see a lot of new packets. They were all sent out from the Mac Mini, but see, there's no any response from the Apple TV because the AP simply dropped the multicast frames, right? Then if I go back to the screen mirroring, click on this button. See, even though in Wireshark, you can see the Mac Mini did try to send out the multicast query, but Apple TV simply didn't respond back. That's why here you don't see Apple TV listed anymore, right? Why Apple TV didn't respond back? It's because, yes, the Mac Mini did try to send out the multicast query, but the access point simply dropped it. That's why the query even didn't have a chance to reach out to the Apple TV. Okay, so now you see the effect, right? So we can double check in the captured wireless frames as well. So in this session, let me stop capturing. You can see if I filter the frames using the VLAN default MAC address for the UDM Pro, I can see a lot of frames, including multicast frames, which is expected. As we just discussed, the access point will not block the multicast traffic from the gateway, right? However, if we change the MAC address to the Mac Mini, you can only see several unicast frames, which also matches what we observe in the Mac Mini's Wireshark capturing, right? Then if we change the MAC address to the Apple TV's MAC address, you can see the Apple TV mainly send out unicast frames to directly respond back to other devices, right? It did send out very few multicast frames, but this is just sourced from the Apple TV, right? So the access point will simply drop these frames, so it won't continue the transmission. Okay, I believe now it's clear about the effect after we enable the multicast and the broadcast control, right? Before moving on to broadcast, let's test this exceptions feature. So let's say in your network, in general, you want to block the multicast traffic in Wi-Fi. However, you do want to open up for selective devices to be able to communicate using multicast. So let me add this Apple TV and this Mac Mini into the exception list. I just added Apple TV, now add the Mac Mini. Okay, then apply changes. Before testing it out in the SSH session to the access point, let me rerun this command to get the exception MAC address. See, now we have two more MAC addresses. They match the two which we just added exactly. Okay, now in the left side Mac mini machine, we can test it out to see whether we are able to see the Apple TV in screen mirroring. Click on it, click on this button. Okay, Apple TV show up now. Okay, this is a very simple validation. Now let's move on to broadcast. In a similar lab setup, I have two Mac minis. They are connected to different UniFi access points. And in the right side, you can see at this moment, I don't have the multicast and broadcast control enabled. So based on the current setup, in the left side Mac mini, if I start capturing, I will capture the Wi-Fi interface, but capture the Ethernet frames. Started. Then in this terminal, let me keep pinging the gateway. Okay, so you can see the TTL is about 6 or 7 milliseconds, right? Pretty good. Then in the right side, let me run this command. I'm using hping3. It's a popular tool to do network testing. I'm going to send out the ICMP packets, and the frequency is very frequent. Every 0.05 millisecond, I'm going to send out a packet. The destination address is the broadcast IP address for this subnet. It's not really flat, but close. Because I'm using a Mac machine, it's difficult to send out real flat packets, but in this way, it's already good enough. So let me run it. Okay, so it's being sent out. Then in the left side, you can see all of a sudden we have tons of broadcast packets. They were all from this .1.84, which is the right side Mac mini, and the destination IP address is the broadcast IP address, right? Then see this continuous ping. It is still running, but see the TTL? They are dramatically increased, right? So now you see the effect. If we do not have this multicast and broadcast control enabled, what effect you will observe if there's some troublemaker who's sending out continuous flooding broadcast. So let me stop this ping. Then in the left side, you can see the TTL resumes to normal, back to 7 milliseconds, right? So then in the UniFi network controller, let me enable the multicast and broadcast control. You can see in the exceptions, I do not have anything, which means neither of these two Mac minis will be in the exception list, okay? Apply changes. Now the configuration change is active. You can see the left side is pretty good, 7 or 8 milliseconds, right? Keep in mind that the Wireshark is still running. You can see at this moment, you don't see any broadcast packets, right? So then in the right side, let me run the command. You can see the right side, the hping3 is trying very hard to destroy the network environment by sending out flooding broadcasting packets, right? But in the left side, you see in Wireshark, we do not see any broadcast packets from the right side Mac mini. And then you can see in the ping session, the TTL is not really impacted by the right side crazy activities at all. Okay, so now you see the effect. After we enable the multicast and broadcast control, the access points did drop the broadcast packets on the air. Okay, we are good for this scenario. Before ending this video, let's briefly talk about this multicast and broadcast control for Wi-Fi and the existing MDNS reflection setting, how they are related. The short answer is they are not related at all. So if I go to the network setting, you can see I can enable the MDNS reflection, and then I can choose which VLAN I want to enable it, right? So this setting is only about whether you want to enable the reflector which is running inside the gateway for each VLAN. It has nothing to do with the behavior of the access point. The setting in your SSID about whether you want to enable the multicast and broadcast control is only about whether the access point will drop a multicast or broadcast packet. It has nothing to do with the packet is from which VLAN. It only deals with MAC addresses. These two features, even though they are both related to multicast, technically they are not related to each other at all. They are for totally two different things. Okay, I hope it's clear. Yeah, this ends the video. Thanks for watching.